Homework 11, section 6.1, discrete random variables, video 9. Sorry if I seem a little flustered. I was recording this video a moment ago. I was close to the end and my phone rang, which ceased the video and I can't just resume. So I put my phone on do not disturb mode. Hopefully if it rings again, it won't end the video. But we're going to calculate the variance and standard deviation of a discrete probability distribution. And if you'll notice on the board, I've already got the distribution from the previous example where we had X was the number of boys in a 3-child family and P of X was the probability of having that number of boys. Also recall that we already found out that the expected value was equal to 1.5. We expected half of the kids to be boys. Before we move forward, I do need to tie up one loose end. In the previous video, I mentioned that there was an alternative way to represent the mean, and that was the expected value by saying E of X. But there's a third way that I forgot pops up in this formula, is to have a mu but subscripted with the name of the random variable. The only difference between these two is that this one is specifically alluding to the fact that there was a random variable whose mean we calculated. So in the formulas you're about to see, they will include mu sub x, which just means the mean of that random variable. So without further ado, here's the formula for variance of a discrete probability distribution. You may recall previously that the variable for variance was sigma squared, but because we're referring to the variance of a random variable x, we're going to subscript that with an x. There are situations in future statistics classes where you're dealing with more than one random variable at a time, so it becomes mandatory to indicate which random variable you're calculating values for. There's actually two formulas for variance. I'm going to show you both of them and show you why one of them is a little better than the other. The first formula for variance is the sum of a squared parentheses times the probability of each x. The squared parentheses is x minus the mean for the random variable. So what we would do for this formula is take each value for x and subtract the mean from it, square that difference, multiply times the probability, and then add them up. Before I show you the other formula, let's go ahead and calculate this one for the previous example. So for this one, to find the variance, we would need to do the following for each value. First, subtract the value minus the mean. The mean was 1.5. So 0 minus 1.5. That difference gets squared, and we multiply times the probability. 0.125. And then we do the same thing for each value of x. So when x equals 1, we do 1 minus the mean, so 1 minus 1.5. That gets squared. And we multiply by the probability, which was 0.375. Plus, we do the same thing for x equals 2. So 2 minus 2.5, 2 minus 1.5, that gets squared, multiply by the probability, 0.375, and then I'm out of room over there, so we'll just do it down here, plus the final value for x was 3, minus the mean, which was 1.5, that difference gets squared, multiply by the probability, 0.125. And then all this goes into a calculator. By the way, there is a way to organize this a little bit more cleanly so that you don't have to put all of this into a calculator at once. You could make a table where you have each x and then you just do the things to it that you need to do. For example, x minus the squared x minus the mean and then squared, and then you multiply by the probability. Actually, we could just append to this table each value that we need to do. We could figure out this minus the mean squared, multiply by that, and then add all the results. But you know what? I've already got this set up, and I'm still a little flustered over the previous video getting interrupted by a phone call. Right now I'm looking for my calculator. Calculator, there you are. So I am just going to put this directly into a calculator, but whatever is best for you to put this in a calculator is how you should do it. I do like taking shortcuts when using a calculator. For example, I know this is negative 1.5, and I also know it's going to get squared, so it doesn't matter that it's negative. 1.5 squared, come on calculator, 1.5 squared times 0.125 plus, this difference is negative 0.5, but I'm squaring it, so it doesn't matter that it's negative. 0.5 squared times 0.375, there's a 7, plus, this difference is 0.5, so 0.5 squared times 0.375, plus, this difference is 1.5, 1.5 squared times 0.125, and I get a value of 0.75. So the variance is 0.75. Before I show you the other formula for variance, I do want to remind you the relationship between variance and standard deviation. To get standard deviation, you simply square root the variance. So for standard deviation, which is sigma by itself, you just square root the variance, so 0.75. And if we square rooted that and took it to 4 decimal places, we would get 0.8660. So variance is, standard deviation is just the square root of variance. I'm going to go ahead and end this video and start another one to show you the other formula for variance, which should give us the same results, and let you decide which one is easier to calculate.